Welcome back to our notes. This is lesson 4.2. We're going to talk about reflections today. On the screen, you can see that I have three vocab words already written down for you. And the idea is we're going to learn about reflections in this lesson. So, reflection is a type of transformation, a rigid transformation that uses a line like a mirror to reflect an image. That line that we use as a mirror or to act like a mirror is called a line of reflection. And then later on today in this lesson, we're going to learn that if you have a translation followed by a reflection, that is called a glide reflection. Now, if we look at the core concepts here, they talk about the idea of a reflection as a transformation. And the idea here is that when you have a reflection, let's say I look at point P and then I map it to P prime, they're equidistant. So they are the same distance from that line of reflection. That also means if the point that you are wanting to reflect is on the line of reflection, it won't go anywhere because the idea is if I move it, I have to be the same distance away. So, for example, if I look at this one that my arrows point at, let's say P is one space away from the line of reflection, its reflected point needs to be one space away on the other side. Let's go to the next page. So here's the rules for the reflections. Now I'm going to write them on the side in terms of our coordinate forms. Okay, because we have our coordinate forms that we learned about in the last lesson. So when we reflect over the x-axis, the idea here is if you have an x and a y value, what it does is when we reflect over the x-axis, it changes the y value to be its opposite, or it's not negative, but its opposite version. If we reflect over the y-axis, I can take the ordered pair, and what happens is my x value changes to be its opposite, and my y value stays the same. Then we have special ones like y equals x. This is a diagonal line, and what happens here is the rule says if I have some ordered pairs, all I have to do is swap where they are in the ordered pair. It's just a little easy swap. And then for the line y equals x, the rule says take your ordered pair and swap x and y, but now make them both their opposites. And that is the rule. And then if you have any other random horizontal or vertical line, we will discuss that later when we get to those. Now, as mentioned earlier, a reflection is a rigid motion, which means when you move it, it doesn't change the size, it just changes the location. So let's look at these four examples here. Now, here, I'm going to have some points, and all these lines are they're not scaled, but I'm not going to scale these. So we're going to get some graphs that fall off the graph. That's okay. But I'm going to do a couple of these. Let's look at number one here. I'm going to plot the point -1, 5, which is way up here. That's going to be my A. Then I'm going to plot -4, 4, which is right here. This is my B. And then -3, 1, that is C. And I'm going to connect these and make a triangle. Now I want to reflect this over the y-axis, which is right here. Now, one way I could do this, and this is how I model this first one, if I have a graph, what I might do is count how many spaces away am I from the line of reflection. So if I look at A, I am one space over on the left, so I need to go one space over on the right, and that will become my A prime. Then I can look at point B. I am 1, 2, 3, 4 spaces away. So I can go 1, 2, 3, 4 spaces away on the right. And this is now B prime. And then C is 3 spaces away. So I go 3 spaces away on the right. This becomes C prime. And now I can connect these. And here is my image. So that's using a graph. I can count the spaces. Now I am going to practice in this next question how to do this with the rules. So, and number two, the rule says the x-axis. I'm going to write really small underneath it to find my A prime, B prime, and C prime. But I guess before I do that, let's go ahead and graph the original points. Let's graph 0, 2. There's my A. Let's graph 4, 5, which is my B. And let's graph 5, 2, which is my C. And I'm going to go ahead and connect these. Again, I didn't scale my graph. That's fine. I do want to graph it along the X, reflected over the line Y equals X. Now, sorry, not Y equals X. Over the X axis. Helps if I can read the question correctly. Now, I'm going to do this with the rules. So the rules would say I can go up here and write A prime, B prime, and C prime. And the rule says for the x-axis, every x and y value, I can transform it into where I can take my x value and it stays the same, but I'm going to make my y value its opposite. So if I look up here with my points, I know all my x values, the 0, the 4, and the 5 will stay the same, but my y values need to change to its opposite. So 2 becomes -2, 5 becomes -5, and the other 2 becomes -2. Now I can just plot those points. So I can go to 0, -2, and that would be my A prime, and go to 4, -5, which is going to be my B prime. And then I can go to 5, -2, and this will be my C prime. And now I can go ahead and connect these. And there is my graph reflected over the x-axis. All right, I realize I just graphed that incorrectly. My A was not at 0, -2. So I'm going to quickly change that up a little bit. I'm going to erase these lines here. My C prime and B prime were correct. My A prime had to be down one more line. I just noticed that. I'm so sorry. There we go. There's my graph. Now, what we're going to do is we're going to do number 3 using a graph, and then number 4, we will not use a graph. We're going to try to do it without the graph. So if I look at number 3, I'm going to move this up a little bit. Look at number 3 here. I'm going to graph my A, B, and C. So A is at 2, -1, and then I'm at negative, sorry, that was A, and then B is at -4, -2. There's B. And then C is at -1, -3. There's C. And I'm going to connect these. I want to graph this reflection over the line y equals 1. So y equals 1 is this horizontal line here. So if I graph it and want to do it based off a graph, I can do what we did before. How far away is A from that line of reflection? I'm 2 below it, so I want to go 2 above it, and now this is A prime. C is 4 below, so I need to go 4 above, which is way up here. There's my C prime. And B is 3 below, so if I go 3 above, there'd be B prime, and now I can connect these. So I don't have a ruler with me, so it's just getting really not clean looking, but that's okay. There would be my results. Now, what if I didn't ask you to graph and I just asked you to do the reflection? So pretend I didn't have this graph here. Okay. So we're not going to actually graph it, but I'm going to erase this. I'm going to use this as an example to show you why this is going to work. I'm going to look and I'm going to try to find A prime, B prime, and C prime. But we're going to reflect this over that line x equals -3. Now, just a visual, x equals -3 is this line right here. So if I have a point and I want to reflect it over the other one, notice I'm changing, when I'm reflecting over the x-axis, I am changing my x value, not my y value. So with that, I can say that my y values and all these are going to stay the same. Now for my x values, it's based on how far away I am from that line of reflection. So if I look at -2, how far away is -2 from -3? All right, if I want to go from -2 to -3, I have to subtract 1, which means I need to subtract 1 more, which would give me -4. Now, if I'm at -2 and I want to go to -3, I subtract 1. So if I subtract 1 again, I get to -4 again. Now, if I'm at 0, how do I get from 0 to -3? I subtract 3. So if I want to subtract 3 one more time, I get to -6. So that is a strategy if you don't have a graph. All right, let's go to the next page. So let's go ahead and reflect these. Now we're going to write down ordered pairs. It'll make it easier because my rules are those special ones where I can't really just graph because the line y equals x, just so you know, is this line right here. And I can't really count how far away I am from there. It's a little bit harder to do. So what I'm going to do is I'm going to start off with what are my A, B, C, and D ordered pairs. I'm going to write these down. So A is at -3, 2. B is at -1, 2. C is at -1, 4. And D is at -3, 4. And my rule says if I have X and Y, and I want to reflect over Y equals X, I'm just going to swap my X and Y values. So now I can find A prime, B prime, C prime, and D prime by just swapping my X and Y values. So if I swap these, A prime becomes 2, -3, B becomes 2, -1, C becomes 4, -1, and D becomes 4, -3. And now I can graph these points. So I can go to 2, -3, and there's my A prime. My B prime is 2, -1, so there's my B prime. And then C prime is 4, -1. So there's C prime. And then 4, -3 is my D prime. And now I can connect these. And that's my new one. Now, some of you might think, well, it looks like I just slid down and to the right. It looks like that because I have a square, but notice where my letters are. If I look at orientation, A and A prime are both in the bottom left. Okay. But look at D. D is on the top left of this square, and here it's B prime. So it wasn't just a true slide down and slide right, because that means D, if I look at A, did A go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5? Okay, look at D. 1, 2, 3, 4, 5, 6, 7. It went down 7, then over 1, 2, 3, 4, 5, 6, 7. Not the same translation, so that doesn't quite work. Right? So the reflection is not a translation. Now, let's look at this next one here, number 6. Same thing. I'm going to write down my A, B's, and C's. The original problem. A is 0, sorry, not 0, 2 comma 0. We're skip counting. You know, look at the X, Y axis. We're counting by twos. B is the point 5 comma 3. C is the point 2 comma 5. And D is the point 1 comma 4. Now, y equals -x says when we take our X and Y values, our transformation that happens is we are going to replace X and Y with each other, but then throw the negatives in there. So make them their opposites. Let's figure out what A prime, B prime, C prime, and D prime will be when we swap the order and then make them their opposites. So if I swap 2 and 0, I'll get 0 and 2. Now I need to make the 2 negative because 0 is neither positive nor negative. If I swap the 5 and the 3, I'm going to get 3. I'll get 5, but let's multiply them both by a negative. And then so C would be -5, -2, and D would be -4, -1. And now I can go ahead and graph these. So 0, -2 is going to be my A prime. Then I have -3, -5. There is my B prime. Then I go to -5, -2. There's my C prime. And then -4, -1 would be my D prime. I can go ahead and connect these. And there is my new trapezoid that I have graphed. All right, last couple problems. Let's look at number 7 here. We'll do number 7. This is a glide reflection. And the question has some points, J, K, and L. And we want to I'm going to use some rules here. Now, you could graph each one individually, but I'm going to use my rules. Again, I'm going to graph J, K, and L. So J is 3, 1. So 3, 1. There's my J. K is 4, 2. And then L is 1, 3. So J, K, and L. Here's my lovely little itty bitty triangle here. Now, if I look at these points, I'm going to first say what's J prime, K prime, and L prime based on our first transformation that we have. The first transformation says I'm going to take every X value and subtract 6. So 3 minus 6 would be -3. Then I'm going to subtract 1 from the Y value. So 1 minus 1 would be 0. Let's look at K. Subtract 6 from 4 and I get -2. And then subtract 1 from 2 and I get 1. Then L, if I take 1 and subtract 6, I get -5. And then 3 minus 1 is going to give me 4. So that was with the translation. Now with the reflection is y equals -x. So I'm going to take my x and my y, and I'm going to then make them their opposites and change spots. So when I do that, I can have a j double prime, K double prime, L double prime, and let's see what we get. For J, I'm going to get 0, 3. I swapped them and I made them their opposite symbols. And K double prime, I'll get -1, comma, +2. And then for L double prime, I'll get -4, comma, +5. So I'm going to go ahead and graph those three. I'm going to graph 0, 3, and that's going to be my J double prime. Then I'm going to graph my K double prime at -1, 2. So there's my K double prime. Then I have, let's see, what's the next one? L, -4, 5, -4, 5. There's my L double prime. So I continue connecting these, and then there is my new, there's my new one. Yeah, so there we go. There is your glide reflection. Now let's look at this next part. If we look at these words, identify the line of symmetry, if any of the word. And that says, can we draw it in there? That means can we fold it on itself? Now moon, I can't go down in the middle because M does not map to the N if I flip it. And then if I do it horizontally, the tops of the N's and the tops of the M's don't map. So there's none on number 9. Number 10, for wow, I can't cut it horizontally because the tops of the W's don't match with the bottoms of the W's. But what if I cut it vertically right here? Half the O ends up with half the O, the W ends up with the W. And with kid, with this font, I can't do it vertically because D doesn't match with K, but I can cut it in half right here. And the top part of the K maps with the bottom part of the K, the bottom and tops of the D match, and so do the I. And then in doc, we can also go horizontally right here. And we are skipping number 13. All right. Sorry, those notes were long, but hopefully you get the idea. If you have any questions, reach out, or we'll see you in class or at the next video. Have a wonderful rest of your day.